Okay, so hello miss, this is going to be my video for the summative grade, solving the 5 exercises that you give me on the document. So okay, we're going to start with the first exercise. I hope that you're seeing very well my page. Okay, so my first exercise is a quadratic equation where we have 9r squared equals 48r minus 64. So the first step that we're going to do for solving this quadratic equation is first rewrite the equation that it equals a 0, for then we can put it on the quadratic formula. So for we can change this equation, what we're going to do is basically replace this equal sign to here and put a 0 next to it, for it can identify that it is equal to 0 the whole equation. So this is going to be the following. So this is going to equal 9r squared. As we are going to replace this one, we are going to change the signs of these two numbers. So this is going to be transferred to a minus 48r, and this one, as it is negative, is going to pass to positive, because we're replacing, so there is the change of signs. This is going to be 64, here's going to be the equal and the 0. Now that we have it in this form, we're going to put it on the quadratic formula, but for you can understand more, we're going to I'm going to show you what is the quadratic formula. So the quadratic formula is the following: is x equals, this is going to be a whole fraction, in the top is going to be minus b, positive or negative, square root of b to the power of 2 minus 4ac. This is going to be on the top, and on the bottom is going to be 2a. Obviously these values of b, a, and c are going to be replaced by the numbers of the quadratic equation that is this one. So okay, the first step was this one, that is already written in the 0 form, that it equals to 0, and then we're going to put this one on the quadratic formula. So in this case, this x is going to be r. It's going to be the following: r equals, we write this, and okay, now for placing these numbers into these variables, we're going to put that 9 is the a, 48 is the b, and 64 is the c. For when we put them in this quadratic formula, it's going to be easier. So taking into account that 9 is a, 48 is b, and 64 is c, we're going to put them. So the first one that we have to put is minus b, so in this case is minus 48. We're going to put it on a parenthesis because the minus b is always negative, and as this is a negative 48, we have two signs, positive or negative, the square root, I'm going to make it here. And okay, so b negative, b to the power of 2 is going to be minus 48 to the power of 2, minus 48 to the power of 2. The minus 4, that is always 4. Then it's going to be multiplying the a, that is 9, times 9. And this is also multiplying to the c, that is 64. And on the bottom part, we only have the 2. There's going to be always going to be 2, and the a, that is 9. And this is also multiplying it. Now we can solve the quadratic formula with the values that we have. So the first one, as is going to be in the first part, that is negative times minus 48. So negative and negative is positive. So it's going to be give us a single 48. Positive and negative. And then for solving out the radical, we have minus 48 to the power of 2, that this will give us 2304. Here I have the calculator. Then the minus 4, that is going to be always minus 4 times 9 and times 64. And this is dividing 2 times 9, that is equals 18. We can already solve it. And okay, now, but we haven't completed yet because we have to solve what is on here. Here is on a radical. That's it. We have to solve the radical for it's going to be more easier then. So then what we're going to do is, well, first I decide to multiply all of this. That is 4 times 9 times 64. That was equals the same. So wait, this is going to be 48, positive or negative, and the radical 2304 minus the other part, that is 2304. That will be it, and this is all dividing it by 18. Now what we're going to do for just eliminate the radical, we're going to do the operation that is right here. Here's a comma. So we're going to subtract these two values, and these two values equal 0. Okay, so our process is going to be 48 positive or negative square root of 4 of 0, and it is all dividing 18. So now what we're going to do, the radical of 0 is always going to be 0, so that's why we can take it out and stay like this: 48 positive and negative, 0 and 18. Now that we have it in this form, what we're going to do is like break it up in 2 for give us 2 answers, but in this case, as we have a 0, every number that we add or subtract by 0 is going to give us the same, so it's no change. So we're going to only have only one answer. That will be the following. That will be R equals 48 divided 18. Not for a final answer, because we can simplify it more. In this case, we can simplify by 6, the two values, by 6, and this will give us 48 divided by 6, that is 8 divided 18 divided by 6, this will be equal 3, and this will be our final answer. As I told you, we only got one answer because the number that we are adding and subtracting is 0, so that's why there is not 2 answers. If there will be a 1 or a 2 or another number that is not 0, there will be having a split answer. So that was our first exercise. We're going to pass with our second one. Okay, miss, here we are with the second exercise that you gave me. In this case, we have a multiplication of complex numbers, and this is the equation that you give me, that is 8 plus 3 imaginary, that is multiplying 6 minus 5 imaginary. So in this case, what we're going to first do is the distributive operation. For this occasion is going to be like this. So the 8 is going to be multiplying with the 6, and this 8 also is going to be multiplying the minus 5 imaginary. And the 3 is going to be multiplying the 6 and also the 5 imaginary. This is this distributive property for solve this type of multiplication. So okay, the first thing is the 8 multiplying 6, so that will be as 48, 8 times 6, 48, and the negative, because then we have the minus 5, so 8 times minus 5 imaginary, that will be as minus 40 imaginary, and then with the 3, so 3 times 3 imaginary times 6, sorry, and that will equal 18, which is positive 18. And then finally we have the 3 and the negative 5, that is going to give us minus 15 imaginary. Here is also imaginary, sorry about that. Okay, now that we already have these values, we can start to solve the equation. Sorry, this is a square, because the 3 imaginary and the minus 5 imaginary, as you can see there, there are 2 i's, and that will give us I to the square. Okay. Okay, now that we already have this, the first thing that we're going to do is take out the imaginary 2, and here we have a rule of math that the imaginary 2 is going to be always -1. It's going to be always replaced by the -1. So that's going to be what we're going to do in this equation. So here we have 48 minus 4 imaginary plus 18 imaginary minus 15 multiplying -1. As you can see, I replace it on the equation. Okay, now that we already replaced it, what we are going to do is solve the signs of these two. So as you can see, here we have a negative, and here we also have a negative. So negative multiplying negative is going to always give us positive. And as 15 times -1, 15 times 1 is 15, we are going to only change the sign. So it's going to give us the following: 48 minus 40i plus 18i plus 15. Okay, now that we already take out the I to the power of 2, we can continue with the operation. So now what we're going to do is basically we're going to take the real numbers that we have on this equation. There are two, that is 48 and the 15. As you can see, they are real numbers because they don't have the I of imaginary numbers. So we're going to take them, and as in this equation the 15 is positive, we're going to add them. So it's going to give us the following. So 48 plus 15, that equals to us 48 plus 15, that will equal 63. And then what we're going to do is take the imaginary numbers. So the minus 40 plus 18, and minus 40 plus 18, that is equals to minus 22 imaginary. And this will be, I'm going to put it here, 63 minus 22 imaginary. That will be our final answer for this multiplication of complex numbers. So what we first do is the distributive property, then we take out the I in the imaginary to the power of 2, replacing it by a -1. Then we add the real numbers that we have on our equation, and then the imaginary numbers, we add them for have our final value of the multiplication. Now we're going to be passing to our third exercise. Okay, so here we have our third exercise, that is the division of complex numbers, and the number that you assigned me was this one: 8 imaginary divided 7 minus 2i. So this is going to be the equation that we are going to divide the complex numbers. So okay, first what we're going to do is basically we're going to be looking for the denominator of this fraction, that is, this case is 7 minus 2 imaginary. What we're going to do with it is that we are going to this value multiply it with the whole fraction, but instead of a negative, we're going to put a positive. We are going to change its sign. So for you can understand me, what we're going to do is the following. So 8 imaginary divided 7 minus 2 imaginary multiplied by the 7 plus 2 imaginary, and on the denominator the same thing. So as you can see, I take the denominator of this fraction and I'm multiplying it with the same values but with a different sign, because here is a negative, we're going to change it to a positive, and the two values is going to be on the numerator and also in the denominator. So now that we are know the values that we're going to multiply, what we're going to do is basically join them, for we can then do a distributive property. So for you can understand me, we're going to do the following: 8 imaginary parentheses 7 plus 2 imaginary divided 7 minus 2 imaginary and the 7 plus 2 imaginary. Now that we have it in this process, it's going to be more easier to multiply, because we're going to do the distributive property on the top, and here we're going to do the difference of squares. Okay, so first this one with this one, and this one with this one. So I'm going to continue here. So 8 times 7, that equals 56 imaginary, because here we have an I, 56 imaginary, and plus 8 times 2, that was equal to 16, and the I, each one of the values has an imaginary, so this will be imaginary to the power of 2. So 16 and imaginary to the power of 2. Okay, that is on the numerator part. And on the denominator, what we are going to do is also do a distributive property for this one. So we're going to do this one with this one, and this one with this one. Not a distributive, difference of squares. Sorry, miss. That I get scared, but okay. So now that we already have it like this, what we're going to do is multiply. So 7 times 7, that will equals 49. And minus 2 times 2i, that will give us minus 4 I to the power of 2, because each one of them has an imaginary. So that y is to the power of 2. So now, following the same rule that we follow in the multiplication process, that I to the power of 2 equals always minus 1, we are going to also replace it on this equation. So there is going to, that is what we're going to do. So 56i plus 16 times minus 1, because here we have I imaginary to the power of 2, and also in the bottom. So we're going to do this, 49 minus 4 times minus 1. So now that we have this, we're basically doing the same thing that we did on the past one, that is changing the signs, because, 16 times 1 is 16, and 4 times 1 is 4. So we are going to only change the signs. So here we have a positive and a negative that we're going to change to a negative. So 65 imaginary, here is negative 16, and at the bottom we have a negative and a negative, that was positive. So 49 plus 4. So as you can see now, we take out the imaginary to the square of the 2 that it was on the 16, and the minus 4. Now we don't have it. Okay, now that we already have this, we're going to basically separate the two fractions, for one is imaginary and the other one real. So what we're going to do is the following. We separate it on the middle, and that will give us 56 imaginary. We first add these two values, that's 49 plus 4, that will equals 53. And now that we have the same denominator for each one of them, we can now split it, the fraction. So as I was writing, 56 imaginary divided 53 minus 16 and 53. So now you're going to be asking why a negative, because the 16 is negative. So that's why this whole fraction is negative. But we also follow a rule that all the imaginary numbers are going to be on the part, on the right part, and the real on the left one. So for changing these ones, we're going to do the following. We're going to write minus, the fraction, 16 over 53, with the minus, because this is negative. And as this one is positive, we write a positive sign, the 56 and the 53, and the imaginary number. And this will be our final answer for this division of complex numbers. As you can see, we have two values, we split it, we have the real and the imaginary value. Now we're going to be passing to the fourth exercise. Okay, miss, so here we are with the fourth exercise, that is determine if this problem is a function or not. So our problem is the following: the correspondent that assigns to a player on a team that player's uniform number. So basically, what we first do, or what I did, was first identify the two variables that we have on this problem. And also first define what a function, what is a function for me. So a function for me is a function that has an input and an output, and that is we're going to be looking on this problem. So okay, we know that we have a player of the team. Okay, that is going to be our input. I'm going to be putting an input and an output for then determine if this is a function. So this is going to be our input, that is the players of the team, and also then we're going to have the player uniform. That's going to be assigned. Player uniform, and this is going to be our output. So as you can see, now that we have like the player of a team as an input and the player uniform as an output, then we can recognize that this is a function, because we can say that each input is joined with one output, because one player of the team is going to have one player uniform. Yeah, so I'm going to write it here. So each input is joined with an output. So I was explaining, one player of the team is going to have a one player uniform. Okay, so then as we can see this is going to be clearly a function. Because it has an input and an output in the problem. Now we're going to pass with the fifth exercise. So wait. Okay, miss. So here we have we are in the last exercise, that is the 5, which is determine f of 3 and determine x values for f of x equals 5. So okay, for this one we need a graph that you show me on the document, but I put it right here for it's going to be easier to explain this and to solve it. Sorry. So first of all, this function is a logarithmic function. That's going to write it here. Logarithmic function. This is a logarithmic function because of the position of the line, how it is on the graph. Perdón que me trae mucho. But okay, this is a logarithmic function. Okay, so for determine first this one that I read it here for solving it. For determine the f of 3, what we are going to do is first localize the 3 on our graph, and this is going to be replacing as x. So that's why we're going to find the 3 on the part of x, en el eje de x. So first we localize it on the graph. So I put a graph that is 2, 4, 6 because of the space, but for localize the 3 is going to be right here. So what we're going to do is draw a vertical line for a new for know where this my line that is going to be 3 is going to intersect with the function. So here we have the 3, and we're going to draw a vertical line on top and to the bottom. And we're going to localize where it does interact with our function. So as you can see, where it interacts is right here. And this point in the y-axis is going to be -3 because it's right here. So we already solved this. This is going to be a -3 where it does interact. So first one, check right here. And second one, determine x values for f of x equals 5. Okay, so first what we're going to do is now localize the 5 on the y-axis and draw a horizontal line to know where it does interact for find the value of x. So in our graph, we know that the 5 in the y-axis is going to be right here, and we're going to draw our horizontal line here and here. So now that we already draw it, we're going to look for where does it interact with our line. So I didn't draw it perfectly, but we're going to use this graph because the one of the computer is like more perfect, but it's more difficult to do. So okay, we're going to see, and where it interact is right here. So in my graph, we can say that is basically a 7 because it's not completely on the 8. So a 7 that is right here, and this will be our answer for this determine the x values for f of x when it is equal to 5. So we'll check this and check this. So okay, that was all the video, miss. Thank you very much. It wasn't too hard exercises. I hope that, bueno, que esté con todo lo que tiene que estar. Y pues nada más, gracias por ver y ahorita ya te lo envío. Soy Miguel Ángel Acosta de décimo A. Ya.